I'm Alexandre Dolgui from France here. Hello, everybody. We would like to present you our talk on supply chain viability, intervened supply networks, and digital supply chain. This will be a conceptual presentation to attract your attention on this very crucial issue in operation management and management science. Our talk will be followed, Dmitry, this outline. We will present the concept of ripple effect and resilience. We work a lot on ripple effect in our research, and then we will introduce supply chain viability concept and intervened supply networks. Present the difference between traditional approaches and this new view of supply chain. Viable supply chain model and reconfigurable supply chain, and then we will speak on the tools to manage and design viable and reconfigurable supply chain as digital twins and intelligent digital twins. For supply chain engineering, supply chain management and control, supply chain stress test, and also on the importance of human artificial intelligence interface in the use of digital twins. The objective of our talk is to delineate novel concepts in supply chain resilience and associated future research area. You can see many books edited by our group with the lead of Dmitry for this activity. So Dmitry, please, for the first part of your talk.
Thank you, Alexander. Hello, everyone. I'm Dmitry Ivanov from Berlin School of Economics and Law in Germany. So today we are going to talk about two parts, viability and digital twins, and we also want to connect them. So we define resilience usually as a capability of a company to withstand, adapt, and recover from disruptions to meet some customer demand and ensure performance, to recover performance when performance is disrupted, right? And more or less, resilience we can compare with an immune system. Each of us has an immune system as a human in order to protect ourselves and recover if we get sick. So, and risks are these viruses, internal viruses, which are threats for our health. The same with the supply chain. Supply chain needs resilience, and resilience is an immune system of the supply chain. Mm-hmm. There are two essential views on resilience. The first view is so-called performance deviation-based view, when resilience is considered as a quantity, as an outcome. This outcome is usually measured by recovery, success, and by some performance deviations. So what is our success in recovery after disruption hit my supply chain? Mm-hmm. The second view is adaptation-based view, where resilience is considered as a system property, it's a quality, aiming at the persistence of system performance. So it's not much about reacting to performance deviations and responding to disruptions after disruptions happen. It's more about creating adaptability inside of system, creating resilience as a quality of the system to ensure persistence of system performance. Right? So, and at the end, regardless of which view we take, only a resilient supply chain can be profitable. One specific area in supply chain resilience research is the ripple effect. Ripple effect is something which describes disruption propagation in the supply chain network And this propagation leads to unavailability of some components at different echelons of the supply chains. Now, the typical example is the COVID-19 pandemic. At the beginning of pandemic, a lot of production and suppliers in China, for example, stopped production due to the first lockdowns. Assembly plants in the United States and Europe were missing components, were missing materials, and had to stop production or significantly reduce production because of the missing parts. So this is one typical example of the ripple effect. And one can contrast ripple effect with the bullwhip effect, which most of us know very well. The bullwhip effect, it's something what we consider as a high frequency, low impact effect, right? It refers more to the process level, say changes in supply on lead time. This is something what we consider in the bullwhip effect. Ripple effect refers to structural dynamics, right? So changes in supply chain structure and disruptions driven by these changes. So this ripple effect, it's say high impact, low frequency disruptions. And interestingly, there are situations which we name disruption overlays, situations when bullwhip effect and ripple effect intersect. So just again, if we recall the COVID-19 pandemic example, due to the lockdowns, due to the ripple effects caused by the pandemic, we had seen a lot of panic behaviors of customers. I think each of us exhibited a sort of panic behavior, buying and hoarding products in anticipating of future shortages. And so ripple effect caused the bullwhip effect. This disruption overlay is actually an interesting topic for future research. Now let us turn to one of the major parts of our talk, viability, as adaptation-based resilience perspective. So again, we see two essential views on resilience. The first view is performance deviation-based view, where we basically talk about the ability of a system to absorb disruption and recover to its original initial performance and structure. So more or less, the focus is on avoiding oscillations in the system and bouncing back to some initial states after disruption. Another view is adaptation-based view, which focuses on the ability of a system to adapt and cope with changing while still maintaining performance. So in other words, here we do not react to every oscillations and every performance deviation. We accept oscillations and performance deviations, and our major target is to survive, to exist, ensure some performance persistence through internal adaptability which exists in system as in business as usual scenarios. So we do not separate disruption-free and disruption scenarios. And adaptation-based view, this is something what we refer as supply chain viability, right? So the difference can become clear if we look at this picture. Supply chain resilience is a sort of closed system view. We have a disruption which hits the supply chain, we assess impact, we develop stabilization policies as we recover, and then we bounce back to the original state. But bouncing back to the original state is not always possible or desirable. And that's why we have the second view on resilience, which we name viability. Adaptation to changes, adaptation as a normal. Right? Adaptation in the sense to survive in continuously changing internal and external environment. So we should not necessarily wait until disruption hits our supply chain. Perhaps it's better to proactively mitigate disruption before it happens through adaptation. In resilience, the focus in the performance deviation-based view of resilience, the focus is more on predicting disruptions and responding after a disruption hits the supply chain. So here we have a clear separation of disruption-free, say business as usual scenario, and disruption scenario. This can work for some situations, so of course, and mostly for say known uncertainty and partially for known unknown uncertainty. But what about unknown uncertainty? Right? When we don't know what can happen, when we don't know the performance. Right? And for example, pandemic or semiconductor shortages are nice examples of these unknown unknowns. And this is exactly where the second perspective, which we name viability, makes a lot of sense. So here the focus is not on predicting disruptions, but on creating adaptability in the network, absorbing and responding before disruption hits the supply chain. So resilience, it's not something what exists outside of system and just waits for emergency case. Resilience is embedded in all businesses' usual decisions. And this works fairly well for unknown unknowns. There are three aspects which make viability a distinct research topic. The first one is that in the traditional view on resilience, we mostly focus on the ability to recover after a disruption as an event hits the supply chain and return to some baseline with the initial original state. In the viability, the focus on ability to operate and continue serving markets and customers in the presence of disruptions, proactively reacting to potential disruptions and adapting our behavior in the presence of disruption. And this is especially important to survivability in the long term. Like earthquake, it's instantaneous events. It hits the supply chain and then we start recovery. But for example, pandemic or semiconductor shortage are not events. These are crises, long-term crises. And we should somehow adapt to this crisis and operate in the presence of this crisis. This is exactly where viability plays an important role. The second aspect is that resilience focuses on economic performance, like, for example, on-time delivery or profitability of the company. Viability takes an extra step and integrates resilience and sustainability through combination of economical and societal components. So viability refers not only to individual supply chain, but also to intertwined supply networks and even ecosystems. So again, viability, survivability under conditions of long-term disruptions and unpredictably scaling disruptions. And the third distinctive feature for viability is that a classical, conventional, traditional resilience system are usually designed to provide a limited range of expected responses based on our previous knowledge. So they are more or less hindsight driven, which works well for known, or known unknown. And viability builds upon adjusting proactive responses in a flexible way to the unexpected. So this is a foresight driven approach which also addresses unknown unknowns. How to implement viability? Right? So first of all, we should define it very quickly. A definition is viability, it's ability of a supply chain to maintain itself and survive in a changing environment through a redesign of structures and replanning of performance with long-term impacts. Viable supply chain model that has been suggested for implementing viability approach in real life, it's based on adaptable structural supply chain designs for supply-demand allocations, and most importantly, adaptive mechanisms for transition between these designs. To illustrate, let us take example of automotive company and COVID-19 pandemic. So automotive supply chains are usually based on cost efficiency principles of just-in-time principles. They are lean. They also operate a large product variety. So, and this is a sort of agile supply chain design. Then we have situation when disruptions as events should be considered. And here we talk about resilient supply chain. Using risk inventory, using some backup suppliers, capacity buffers, we can change in case of this event-driven disruptions from lean supply chain design to resilient supply chain design. And then we have survivable supply chain design. So where we talk not only about event-driven disruptions, but about long-term crises, like COVID-19 pandemic. Take example, Ford or other companies, automotive companies, most of them repurposed production from car manufacturing to, say, urgently needed PPE, EME items. They changed also supplier-based logistics. So this is another part of adaptation, right? So, and each of these levels corresponds to some stressors. If we have operational stressors like demand fluctuations, here we talk about lean, agile supply chain. If we have some events like natural disasters, then we talk about resilient supply chain. And if we have something of a global long-term disruption crisis like pandemic, then we talk about survivable supply chain design. Interestingly, these three different levels of designing the supply chain can be considered as three kinds of supply chain network. The agile supply chain we can consider a system of the first kind, system which tackles known and able to operate in an efficient and responsive way under business as usual scenarios in the presence of some known operational disturbance. Then we have resilient supply chain design, and this is known unknown. It is a system of the second kind. The system which is able to withstand and recover after disruptions, to restore some initial performance, original performance and structure, using some expected, predefined recovery policies. And finally, we have the third kind of system, the viable supply chain system, which is able to develop new adaptation rules. So it's not about applying already existing rules, but adapting rules in the presence of unknown, maintain itself and survive in a changing environment. With the viability, a new notion of intertwined supply network comes. Right? Supply chains are usually intersecting with other supply chains. Right? If you take, for example, automotive and healthcare supply chain, two different supply chains, two different ecosystems actually, but the same company can play the role of supplier in automotive sector and be at the same time, say, producer of valves for respirators in the healthcare supply chain. So, and here we have a lot of cycles, a lot of changing behaviors where companies play the behavior of buyer and supply in different supply chains at the same time. One example, so we have, say, a semiconductor supplier, and the semiconductor parts are used in three different supply chains. Right? They are needed in automotive supply chains, they are needed in electronic supply chain, and they are also needed in healthcare supply chain by medical supply. So more or less, we have three different supply chains produce and store almost the same substitutable product. For example, displays. Displays which are needed in the cars, displays which are needed in the smartphones, displays which are needed in medical devices. Right? So, and in this case, we have a lot of synergies, right? So, in terms of intertwined supply network, looking at the resilience from this perspective, we see how to use cross-industry adaptation, inventory capacity sharing, cross-industry collaboration to improve resilience. And second, here we also see a very clear shift from resilience of individual supply chains to viability of the whole ecosystem, right? So mobility ecosystem, communication ecosystem, healthcare ecosystem, right? In the end, it's maybe not so important if one particular supply chain will not survive through crisis. Most important that we secure viability of the whole ecosystem, right? That we get cars in mobility ecosystems, that we can call our friends in the communication ecosystems, that we can find doctors and probe medical treatment in the healthcare ecosystem. Right? So, of course, there are also challenges and which are very much related to data-driven approaches, which are currently very popular in management science operations research. So, analysis of such systems would require data on the product component level and not only on the network structure level to understand what components are shared by supply chains of different industries. And something what is very much connected to intertwined supply networks are reconfigurable supply chains and multi-structural dynamics. So most of us know reconfigurable manufacturing systems, RMS. Reconfigurable supply chains have some specific features which differentiate them from reconfigurable manufacturing systems. First, in supply chain, we have active goal-oriented behavior of companies. Second, we have networking effects across multiple structures. Like, for example, disruption in information structure, like cyber attack, will immediately have impact on the process structure, on the logistic structure, and organizational structure. And third, we have network complexity. So multi-echelon supply chains instead of, say, a one manufacturing system within the company. Now I would like to hand over to Alexandre, and before doing that, we were thinking that actually, so we work with companies, right? We work with companies, we know practice of resilience and know practice of digital supply chain, we know what happens in industry. And analyzing, reflecting on this industry and research projects, we can see that robustness and agility parts of resilience are very well explored and understood by managers. However, another important capability, say cognitive capability, visibility, it's something what is of high interest, but still less understood and used. And this is exactly what we would like to discuss in the second part of our talk, how digital technology, digital twins can help improve resilience and viability. So at this stage, I stop sharing my screen, and Alexandre can start sharing his screen.
Do you see my slide?
Yes, perfect.
Okay, the same. Huh? You can see exactly the same. What is? Now, which are the tools to analyze viability, to design viable supply chain, to increase the quality of our supply chain. And our opinion, these tools could be digital twin. But which digital twin, how to design the digital twin, and how digital twins will be used in supply chain engineering and supply chain management, in viability analysis and performance evaluation. We know many digital twins now, especially in product design, designed by mechanical engineers, in process design and organization analysis. We can exploit this experience to design the digital twin for designing digital twins for supply networks and networks of networks. What is the component of digital twin? Well, first of all, it is not possible to have an unique digital twin, only one digital twin for supply chain. The digital twin will depend on how we use this digital twin. In this talk, we speak on a digital twin for manager, for decision maker at the management level. So all the components, all the goal of the digital twin will be to help decision maker at the management level to understand better his supply chain, to increase viability and adapt the supply chain to disruptions. There are several components of digital twin. The first one is digital technology. With existing digital technologies, Internet of Things, IoT, blockchain, sensor, cloud, ERP, and so on, we have this possibility to obtain all necessary data in real time for our supply chain. Then the next elements necessary to design a digital twin is the tool to obtain the virtual representation of the physical object in the supply chain, to modelize, to simulate floors, warehouses, but also decisions in the supply chain and planning and control algorithms. The next one, it is predictive and prescriptive analytics, based on the available data, physical data from the supply chain, but also the data from cyberspace. We will be able to simulate, analyze, and optimize our supply chain. And of course, descriptive analytics, allowing us to propose decisions and to forecast evaluation of the situation on the supply chain and suggest a decision for decision maker. For digital twin and operation management, digital twin is supported by, first of all, the digital twin are supported by real-time technology, and which allow data collection, data processing, cleaning of data, labeling of data, visualization of data, generation new data in the system. Digital twin is combination of different model for simulation of real physical process, physical flows, optimization of this physical flow, and what is very important, visualization. When we use digital twin, we can visualize in real time our supply chain. Visualize, test different scenarios, different situations, and optimize this supply chain. Digital twin include not only internal data from physical process, from flows of the supply chain, but also as I said, from cyberspace, from big data from external system to our supply chain. And digital twin is knowledge driven, knowledge transferring and knowledge creating system with human decision maker in the center, and this friendly interfaces with human decision maker. This is an example on our previous study on digital twin for supply chain and for resilience and viability analysis and stress testing of supply chain. The study was done with any logistics software for simulation. So there is three parts of this analysis. The first is analysis of big data, the situations in different regions of the world, and detection of critical situations to give alert to our supply chain. then we have the simulation model of our supply chain wide world, and if a critical situation or a specific risk is detected by our big data analysis, we will zoom on this part of the of supply chain and analyze what will happen for our supply chain, and we will do stress testing of this part of the supply chain to know which consequences will be for our supply chain, how long the time of disruptions, what are possible recovery solutions, possible solution for this situation, and we will select the best of recovery plan for the situation, and we will analyze possible performance for different solutions in term of the costs, times, consequences for viability of our systems, and so on. There are different types of digital twin which can be used for viability analysis of a supply chain. The first one, the mostly discussed, is the digital twin, which is which two part, the physical supply chain and the digital supply chain for simulation and visualization of the current state of supply chain, with optimization tools to optimize the current operation of supply chain, for forecasting and so on. But this type of digital twin is often used for first type of resilience analysis, as presented by Dmitry. The next more complex digital twin is cognitive digital twin. This cognitive digital twin is the simulation, optimization, forecasting plus artificial intelligence algorithm to generate decision rules, but decision rules proposed by decision makers. It's this fixed decision rules developed by decision makers and integrated in a specific artificial intelligence as expert system, for example, as decision tree and so on. And the next is this type of digital twin more appropriate for second type of resilience analysis. And the next and most powerful digital twin is knowledge creation and self-learning model, where the model learns in the data, and it is able to create new decision rules and new optimization model. For example, in the current project, we develop a digital twin which is able to learn from the data of our supply chain and generate automatically optimization model based on the principle of constraint programming. We learn in the data the existing constraint is the system, and this model is optimized when designed. The first, as I said, the first digital twin is visualize physical supply chain, collect and process data data and use them for modeling. The cognitive digital twin, in addition of function of digital twin, it also mimics human decision making and suggests actions. And finally, intelligent digital twin or cognitive. It is a cognitive digital twin plus not only mimic decision making rule, but a human, but a new knowledge and decision making algorithms, self-learning and human artificial intelligence collaboration. It helps humans understand the system better and can even take over some portion of decision making. This last intelligent digital twin is adapted for the last type of supply chain analysis. The first is for resilience system of the first kind, ability to react when something happens, and the operational performance pass a certain level. The second for resilience analysis of the second kind system that learn from what happened to adjust future responses and monitor rules. And the last one is for has ability to anticipate, to proactively mitigate disruption before they appear, based on real-time data and human artificial intelligence collaborations. The focus shift to the adaptability and performance persistence. It integrates monitoring, event-driven response, learning, and proactive decision support for decision maker. Our objective is to switch from the case where system is analyzed in his large environment to focus on the system itself, because we are in the uncertainty space, and it is necessary to design this supply chain to be viable and adaptable on disruptions. It is not possible to predict environment as on the past, and to base our algorithms only on the past data and prediction of the future evaluation. So we focus on the system with embedded resilience, the structural variety, process flexibility, reconfigurability, adaptability as in control theory, adaptability, and so on. Digital twin support monitoring, disruption prediction, event-driven responses, learning, and proactive thinking. Supply chain mapping, illuminated digital shadow, and proactive disruption recognition. Digital twin help map une no. To finish our talk, I would like to present some trends in this domain. This is the number of research papers published from 2014 till now, close to 400 papers about viability and ripple effect. And Our first publication was before 2014. And if you consider journal, the first, it is journal International Production Research. So I am editor-in-chief of International Production Research. So I invite you to submit the paper on these topics to our journal. You can see here also two papers of our group in International Production Research, two recent papers. The first one and the recent paper. We published also several special issues on viability, supply network, and ecosystems in IGPR and Omega also, where we discuss different methods of viability based on biological system, on control theory, and operational research and management science, data-driven optimization, data-driven robust optimization, constraint programming, simulation, and so on. There is an open call for IGPR on stress test for supply chain with David Simchi-Levy. This call is open till the end of July, and call is available on the website of the journal, and main topics. It's not limited to this topic, the main topics: stress testing, supply chain, to material, information, financial, energy point of view, stress testing for future price disruption, stress testing for supply and transportation capacities, reconfigurable supply chain, combination of network analysis and optimization method for reconfigurability, supply chain and cross-industry adoption, supply chain design, digital twin for stress testing as presented in this talk, and cloud supply chain, and so on. So for summary, I invite Dmitry to summarize our talk.
Thank you, Alexandre. Yes, to summarize so that we are good in time. Basically, our key message is that supply chains currently experience a lot of transformations, and we can expect more and more transformation in the near future. Right? Drivers of these transformations are, on the one hand, positive drivers, this digital technology; on the other hand, negative drivers, crisis and disruptions. And so digital technology and resilience are transforming supply chains toward reconfigurable, adaptable, and resilience-centric networks. Of course, efficiency is important, but resilience should become a part of every integral part of every decision in supply chain. And here we get a new context: viability, just ability to exist, to survive through adaptations. There are two ways of designing resilient systems which are actually complementary and not contradictory. They just look at different type of knowledge about uncertainty and attitude to uncertainty by decision makers. If we talk about known, of course, we can use, say, performance deviation-based approach and considering resilience as an outcome or quality. But if we look at unknown, and even known unknown, then perhaps it's better to focus on adaptation-based view, on the system, on something what is under our control, instead of trying to predict actually unpredictable. Right? And so both approaches can be helpful and effective depending on the knowledge of uncertainty and attitude to uncertainty by decision makers. On the technological level, digital twins is a very promising research area to implement both views on resilience, reactive and proactive. And we see here a lot of future areas which we addressed in this call for papers, for new special issue, but also in some other publications. First of all, we can expect development of new theories and business models based on the viable supply chain, intertwined supply network, and reconfigurable supply network approaches. Then the field is very multidisciplinary. Right? If you look at viability is something what has its origins in biological systems. but we also see a lot of control system engineering approaches to resilience and viability. And of course, operations research management science has created a very large body of knowledge in this area. Multidisciplinary approach can help here to improve. And another direction is to look shift from offline modeling to data-driven digital supply chain twins. One very exciting area is human AI collaboration. So, and at the end, we all want to understand the role and value of real-time data for decision making. Right? How a future supply chain manager will take decisions. So with that, I think, Alexandre, you can change to the last slide where we thank the audience for attention, and we are very happy to discuss if you have any questions.